Good morning, students. Today we will start with a new topic, that is graphical representation of motion. Now, graphs are considered to be the best tools to represent the motion of an body or an object, or it is considered to be the most convenient method to present basic information about a variety of events. For example, you must have seen a graph showing the runs scored per over by a cricket team on your TV, isn't it? The vertical bar shows the runs scored by a team in different overs. You all watch TV, you all watch cricket, so you all must have seen this. This type of graph is known as bar graph. The To describe the motion of an object, the line graphs which we use shows dependence of one physical quantity such as distance or display or velocity on another quantity such as time. Now, in this class, we will be learning about different types of graphs. The first graph which we are going to study now is distance time graph. Now, distance time graph shows how the distance of a body from a fixed point changes with time. Now, to draw distance time graph, what do? We take the distance traveled by the body along y-axis. Okay, and the time taken by the body to travel the same distance is plotted along x-axis. The first graph is distance time graph for a stationary body. Stationary means that the position of the body does not change with the passage of time. Suppose that the distance of a stationary body, okay, is at 4 meter from a fixed point O at time t equals to 0. Now suppose at time 1 at after 1 second or 1 minute it is at 4 meter only. After 2 minutes 4 meter, 3 minutes 4 meter, 4 minutes 4 meter, and so on. So what do you find? That after the distance remains the same but the time goes on increasing. So the distance time graph for such a type of body is a line parallel to y axis, or sorry, x axis or time axis. So this is the type of a graph which you get for a stationary body. It is a straight line parallel to time axis or x axis. The next type of graph which we will be learning now is the distance time graph for uniform motion. Now, uniform motion, you all know that if a body travels equal distance in equal interval of time, then the motion of a body is known as uniform motion. So the distance time graph for uniform motion is a straight line as shown in this graph. Okay, just see, suppose that the distance traveled by an object in time 1 minute or 1 second is 5 meter, in 2 seconds 10 meter, 3 seconds 15 meter. So it is getting uniformly increasing. So the distance is uniformly increasing with the regular interval of time. In such a case, the type of graph which you will get is a straight line. Okay, as shown in this figure. And the distance time graph for uniform motion is used to determine the speed of an object. You know that speed is equal to distance by time. So this graph is used to determine the speed of an object. The third type of graph which we will be studying now is distance time graph for non-uniform motion. Now what is non-uniform motion? You all know that when a body covers unequal distance in equal interval of time. Now when the speed of the body increases with the passage of time, okay, then the type of graph which we will get is this. So this type, it is an increasing curve. Okay, in that case we get a graph which is in the form of increasing curve when the speed of the body increases with time. Now when the speed of the body decreases with time, in that case we get a graph which is of this type. So we studied about distance time graph. Three types of graph we studied. For a stationary body, in that case the graph was a straight line parallel to time axis or x axis. Then for a uniform motion and for non-uniform motion. Now we will be studying the next type of graph, that is velocity time graph. Now velocity time graph shows how the velocity of a body changes with the passage of time. Again, in this case, to draw velocity time graph, we always take velocity on the y-axis and the time along the x-axis. The first graph which we'll be studying now is when a body is moving with constant velocity. So the velocity time graph for a body moving with constant velocity means velocity remains constant. Suppose that, and in the first hour when in the first hour the velocity of the body is 50 km per hour. In the second hour also it is moving with the same velocity, that is 50 km per hour. Then in the third hour also it is moving with a velocity of 50 km per hour. In the fourth hour also its velocity is 50 km per hour. In that case, what do you find? That we get a straight line parallel to time axis. This is the velocity time graph for a body moving with constant velocity. Children, remember that velocity time graph is used to find the magnitude of displacement. Okay, distance time graph was used to find the magnitude of speed. Here velocity time graph is used to find the uh, magnitude of displacement. So the area enclosed by velocity time graph and the time axis will be equal to the magnitude of the displacement. You know that velocity is equal to displacement by time. So displacement equals to velocity into time. So with the area which will be enclosed, it is used to find it. This is equal to the displacement. Next type of graph, velocity time graph for uniform motion. Now for uniform motion means that the velocity of the body is increasing by an equal amount in equal interval of time. For uniform motion, it is showing an acceleration. So you will get the graph in the form of a straight line as shown in this figure. This is for uniform motion. Now come to when the velocity decreases uniformly. Okay, in that case what is happening here, the velocity is increasing uniformly, so we are getting a straight line in the upward direction. Now when the body velocity is decreasing uniformly, in that case we will get in the curve which is the straight line in the downward direction, means the velocity is decreasing, so we are getting a retardation. Now, velocity time graph for a non-uniformly accelerated motion or non-uniform motion. In that case, the graph which you will get, suppose that the body is velocity of an object is increasing at a constant rate up to 2 seconds. Okay, so it is increasing at with a velocity of 30 meter per second for 2 seconds. Then its velocity is decreasing for, suppose it is at 15 meter per, it is decreasing at a speed at a velocity of 15 meter per second for 4 seconds. Okay, again it is increasing for 6 seconds and then decreasing to 12 seconds. Now in this case what you are getting a velocity time graph for a non-uniform motion. It is in the form of zigzag form, so it is a velocity time graph for non-uniform accelerated motion. So children, you have to draw these graphs in your physics copy and understand this thoroughly. Thank you.